A horizon line on an oblique photo can also be used to determine tip and tilt. In this example, the original negative of a 9x9 trimetragon photo has been used as a transparency. Notice that the film holder has been enlarged to accommodate the negative, and that the focal length of the iconoscope matches that of a 6-inch trimetragon camera. To establish tip and tilt, first set the height of the point source of light at exactly 9 inches above the drawing board. This is indicated on the calibrated vertical post. Also at 9 inches above the drawing board, erect a horizontal line. This represents the true horizon. The horizon on the transparency, however, is the apparent horizon. Let's look at these two horizons at a blackboard. This represents the Earth. A camera in a plane. The true horizon, horizontal. The camera sees the apparent horizon, where the Earth rolls out of sight. The angle between the apparent horizon and the true horizon is the dip angle. This angle can be computed in minutes as 0.9878 times the square root of the altitude in feet. If this altitude was 10,000 feet, the dip angle would be 98 minutes, or 1 1/2 degrees. On our drawing board, we have established a horizontal line representing the true horizon. By setting the horizon of our transparency on this line, we can establish the position of the apparent horizon at the true horizon. Now, if we lower the iconoscope an amount equal to the dip angle, we can bring the apparent horizon into its true position. This will put the iconoscope into the same tip and tilt that the camera had at the time the picture was taken. Now let's dim the lights and set the iconoscope. Set the horizon of the transparency, which is actually the apparent horizon, on the true horizon line. Now tilt the iconoscope downward an amount equal to the dip angle, 1 1/2 degrees. The plan projected on the drawing board is now a true plan. If it does not fall in a convenient place on the board, simply raise or lower the iconoscope until it does. Movement in a vertical direction increases or decreases the scale of the image, but does not change its proportions. Wing pictures of trimetragon photos, such as these, can be used to establish valuable control points for mapping. The horizon method of orientation is particularly useful in the Pacific, where many reconnaissance photos have a water horizon. Oblique photos may also be used in combination with vertical photos to establish detailed information concerning terrain levels, beach gradients, and enemy installations. Here are a vertical photo and an oblique photo of a shore in Sicily. 3 orientation points on the vertical photo are marked. The corresponding 3 points of the oblique are marked on the transparency. Wherever possible, all 3 points should be taken at water level. In this example, 2 points are at water level, and a third lies inland at an elevation given on the map as 35 meters. An enlargement of the vertical photo is mounted on a drawing board. The focal length of the oblique photo was 20 inches. The iconoscope, however, can only extend to 14 inches, even with this extension arm. Therefore, the transparency was reduced to 1/2 the size of the original negative, and a corresponding reduction made in the focal length of the iconoscope, in this case from 20 inches to 10 inches. Raising the zero level of the selected points to a fixed distance above the drawing board by means of these cross lines ensures a more accurate setting of the iconoscope. This scale, with its zero at the same distance above the board, marks the location of a point 35 meters in elevation. The scale is calibrated to the same scale as the vertical enlargement. To line up, first get the two foreground points into coincidence. Bring the third point onto the vertical line. If the projected point is below the cross line, tilt upward and lower the iconoscope until all 3 points are in coincidence. Secondary adjustments will be required, but the whole process should not take more than a few minutes. When the 3 points of the transparency are lined up on the corresponding 3 points of the drawing board, the iconoscope will have the same tip and tilt that the camera had at the time the picture was taken. Now we can measure heights, just as we did at the Palau Pier, by placing this scale in the true position of the object to be measured. Here's the chimney. "27 meters high. The ramp at water's edge, 30 meters long, 5 meters high. The viaduct, 17 meters above sea level, 5 meters high. The lower fork in the road, 25 meters high, and so on. Another problem solved with vertical and oblique photos was this plan of Peleliu Island. The available vertical coverage stopped here, and the plan of the rest of the island was required. This was the photographic coverage. An enlargement of the vertical was mounted on the drawing board, and the transparency of the oblique oriented to it using 3 points at water level. The balance of the island was then projected on the drawing board. The iconoscope can be used for purposes other than the rectification of aerial obliques. Ground photos, such as this one of a railway viaduct, can also be rectified. This is done by projecting the image onto a vertical board. When the top of the viaduct is level, its vertical is vertical, and when all arches are the same width, the projection will be a true elevation. Now another use for the iconoscope, the construction of target perspectives. First, a vertical photo or contour map is placed in this special frame. By tilting the frame to the desired angle, the vertical view can be transformed into a perspective. When the frame is properly tilted, the target perspective appears on this vertical board. Pulling straight back makes an enlarger of the iconoscope, and tilting gives the desired perspective. The iconoscope is intended to augment present methods of photo interpretation. Vertical coverage is still preferable. However, when it is impossible to obtain good vertical coverage, iconography will be found useful. The simplicity of the iconoscope is such that any photo interpreter will be able to understand and operate the unit. If the iconoscope is used for mapping, a knowledge of photogrammetry will be required. Further information on iconography can be had in this booklet on application to the Office of Strategic Services, Washington, D.C.